Alright, so in this video we are going to talk about fasteners, and specifically we're going to talk about screws and bolts and power screws. Obviously there's other ways to fasten things such as rivets and welds. Okay, and we're going to start our discussion off by talking about the thread and a little bit of the history behind some of the conventions that we use here in North America and abroad. The global fastener market, just as a point of the global fastener market, is estimated to be greater than $80 billion. And fasteners don't really need much of an introduction because anybody that's lived into their college age years has experienced screws and bolts and power screws, probably even if they didn't know the difference, and certainly in your other classes you've been exposed to them. Alright, so let's jump right in and start talking about threads. And when we talk about threads, we are talking about the same for that the threads are the same for both bolts and screws. Okay, not power screws. And we'll talk about that a little bit more. When we talk about threads, we're talking about the threads that we would commonly encounter in a bolt and a screw. So that begs the question, what makes a bolt versus a screw? So what's the difference? What's the difference between a bolt and a screw? Well, in general, bolts are used to assemble unthreaded objects. Okay, and need a nut. I know this seems pretty obvious. Screws are used with threaded objects in general, even if they make the threads while being inserted. So that's the main difference. I'm sure you could probably extrapolate this to a little bit more detail, but I think that's sufficient for what we need to talk about. One more thing difference is the screws, they have to be turned. Okay. Whereas bolts, you can fasten them without turning them if you turn the nut on a bolt. Alright, so let's go back and talk about threads. And what's interesting is with threads, when we talk about threads, the threads are actually the same standard in the US and abroad, except for the units. And obviously in the US we use US or imperial units or inches, and then abroad, Europe and abroad, we use ISO, standards, or these are usually in millimeters. But they have the same definition of the thread, and we'll get into that. Threads can be single threaded. You can have single thread, right hand thread, or you can have a multi-thread screw, and this is usually used in power screws. Okay. And in power screws, they can have up to 4 threads. And when we say, single threaded or multi-threaded, we're talking about the number of threads per lead. And we'll just write down what that looks like here. So we have the outer diameter of a screw, and this is the inner diameter of the screw, and this is the thread of the screw out here. And if this is where the lead starts, the thread starts and stops, then we call it single threaded. If we take a look at the screw, if we come out here, look at the screw axis, and we look here, you see this is a helix of the screw that's wrapped around. And I know this is not a perfect helix, but you get the picture. Okay, this would be a right hand screw or bolt. And it is single threaded, and it's single threaded because if you look at the lead, and the lead is where the same thread comes to the same position. This is the lead L. You see that there's a single thread in the lead, and in this case the lead is also equal to the pitch of this thread. All right, if we have a multi-threaded screw, then we can draw same geometry where we have our screw diameter and our thread diameter. And in this case, let's say we have a 2 threads per lead. We'd have a thread that would start here and another thread that would start here. So if we looked at the axis of the screw, and if we wanted to draw a left-handed lead in this case, then we could do this and come down here. So that would be a thread. And notice how the thread taper is now going down to the left versus over here where it's down to the right. And for multi-threaded, we actually have the other thread that comes down here and would go between that lead. And so if we take a look at this lead, we still have the lead is defined as, from thread to thread. Okay, so that's our lead. Okay, that would be the lead for that. And then the lead for the orange is going to be the same. So we have the same lead, but in this case we have half the pitch. Okay, and you can see that by this distance here. So this is your pitch distance, and that's the distance between adjacent threads. You can see here how this different geometry looks. And so over here, this is a left hand multi-thread screw. Now, incidentally, both bolts and screws, we talked about what the differences are. They have a screw axis, and this is actually a mathematical term. And a screw axis is just it's an axis for which there's a helical path that goes around. So as you go around the helical path, you get rotation plus linear motion about the screw axis. This screw axis is also called a helical axis or a twist axis. And it's where the line is both the line of rotation and the line of linear translation about that axis. All right, so now let's talk a little bit about the standards for different bolts. And the standards are the standards that we use to make sure things fit together. And there's two standards that we consider. One is the UTS, which is the Unified Thread Standard. And that's used here in the US and Canada. And in the standard we have UNC, which is Unified Coarse Thread, and we have UNF, which is Unified Fine. We also have an extra fine thread that's defined that you can look up as well. Historically, the UNC was previously called the USS, or United States Standard. And the UNF encompasses or was previously the SAE standard, and that is for the Society of Automotive Engineers. So the UTS encompasses the SAE, the USS, the UNC, and the UNF. So don't be too confused when you see that. In Europe, we have the ISO, which is the International Standards Organization and they defined a thread standard that's used abroad. Incidentally, both the thread standards they share the same thread geometry, and that is a thread geometry where you have this thread, and imagine these are symmetric for the sake of our discussion. And these dimensions here are the pitch divided by 8, and these dimensions here for the bottom is P over 4. This area up here is called the crest. This area down here is called the root. This dimension here is the root diameter, or dr. This dimension here is called the major diameter, d. And there's a another diameter that we use, and that is the pitch diameter. Now, to find the pitch diameter, we imagine that there's a perfect triangular thread, and this perfect triangular thread, if we were to bisect it, then this diameter here is the pitch diameter, d sub p. That is our pitch diameter. Okay. The angle between threads, between here and here, is 60 degrees. And so like if you were to buy a thread cutter, it would look like this. And for cutting external or internal threads, if you could fit it in there, it would look something like this. And that would have a 60-degree thread cutter, and that's the common thread. The height of the thread, h, is the height of this triangular square wave here, and this height can be calculated as √3 over 2 from geometry of the pitch length. And there's other non-standard thread geometries that are defined, or specialty threads, but these are the most commonly used and probably the most likely that you would use in your machine. The area that's used to calculate the screw or bolt stresses is the average area. So it would be your pi d squared over 4, and in this case we take the average diameter, and this is the average diameter between the root diameter and the pitch diameter, and we square that, and this is the smallest possible area considering the thread, and this is the area that's used to calculate bolt stresses. One of the differences between UNC versus ISO is that the UNC for sizes less than a quarter an inch, they use numbers, and the numbers are a number 0, number 1, number 2, and then it goes all the way up to a number 12 size. So if you're in Lowe's or Home Depot and you're trying to find a specific size that's less than a quarter of an inch and you get into these numbers, that's what that's from. The ISO standard, they're always in metric, so there's a one-to-one relationship between the size of the bolt and the actual size in the metric system. So you can go and you can look up, these are just some, for example, some hex bolt sizes that I looked up at Bolt Depot, and you see this is a number 4, which is below a quarter of an inch, and you go from 4 to 6 to 8. This last number here is the number of threads per inch, and then you get, from a number 10, then you get into quarter inch. So you got your quarter 20, that's your coarse thread, and you got your quarter 28, which is your fine thread, and that's the number of threads per inch. And you can see just how the two bolt sizes and threads look real quickly here on Bolt Depot. If you also go, you can look and you can see there's so many different types of fasteners. They have different heads, they have different locking, they come with little bits of washer, little bits of details to make them hard to get out. And there's all sorts of options that we don't really cover, but I guess just suffice it to say that there's all types of specialty fasteners that can be used. One more thing to mention is the concept of classes. Okay, so you have different classes of bolts. Basically you have class 1 through class 3. Class 1 is a lower class, so they're loose fit, lower tolerances, and they're cheaper. And class 3, which would be the sort of premium class, you have tight fit, high tolerance, and obviously for those reasons you'd have a more expensive. Okay, if you look at somewhere in the machinery's handbook or something like that, you can see that there's all sorts of different variations for how you can cut different bolts and screws if you were to machine them, but this covers pretty much the standards that we use for most parts that are designed.